So similar figures are pictures, figures, shapes, anything that is exactly the same and you can recognize it as being the same image, possibly different sizes. So to give you a better idea, I took some pictures. So here's a figure. And here's the same figure. Here's the same exact figure. And another the same figure. They're all the exact same figure, same shape, but they're just different sizes. So these are considered similar figures, all right? So let's write that down. So what it means to have similar figures means figures similar figures are figures that have the same shape but can be different sizes. All right, so similar figures are figures that have the same shape but can be different sizes. So some facts about similar figures. They have congruent corresponding angles. So that means that in this image, the angle here is the same size as this angle here, same size as this angle here, and same size as the angle here. So in this figure, no matter how big it is, the angle opens the same amount in all of these similar figures. So we're going to write that down. Similar figures have, I'll make it at 2 bullets. First, congruent. Congruent means same size or same measurement. Corresponding. Angles. So when you see the matching angles in similar figures, that means they're going to be the same size. And the second thing about similar figures is their corresponding sides are proportional. So they have proportional corresponding sides. So when you see two figures and you see sides that are matching, they're going to form a proportion. So I'm going to show you what that looks like. So let's look at the first example. Which rectangle is similar to rectangle A? So rectangle A will be a 6 by 3. I have graph paper, so it's easier. If not, you can just kind of estimate. And we'll say figure B is another rectangle. That's a 6 by 2. And figure C is another rectangle. That's a 2 by 4. All right, so which rectangle is similar to rectangle A? Meaning, if I were to take a picture of rectangle A and I can scale it down or scale it up, which one of these would fit that perfect shape. So mathematically, sometimes you can't really tell with the naked eye. So we're going to have to do some mathematical proofing. So what I'm going to do is I'm first going to circle the corresponding sides because we need to also match the corresponding sides. So I know that side 6 on this one, side 6 on this one, and side 4 on this one, I'm sorry, are all corresponding sides. Those are all the bottom or the base of the rectangle. And the height 3 corresponds to this side on figure B, and 3 also corresponds to 2 on figure C. So I used green and blue. So 2 things, right? The facts say that the congruent corresponding angles. Well, we know all rectangles have 90-degree angles in all 4 corners. So they do have congruent matching angles. Second thing we have to check is proportional corresponding sides. Do they have proportional corresponding sides? So we're going to build proportions to double check that. So first I want to compare, is it going to be A and B are similar? Or is it A and C that are similar? So let's see. How do we set up a proportion? Well, A, side 6, corresponds to side 6 on this B. So we're going to say 6 corresponds to this 6. And is that a proportion that's equal to 3 corresponds to 2? And we check to see if that is a true proportion. So how do we check if it's proportional? Do you remember? Something that you should have learned last year, and that is to do cross multiply. Some people call it the butterfly method. And that just means you're going to double check that the cross products are equal. 6 times 3 makes 18. 6 times 2 makes 12. So clearly they are not proportional. Okay? So let's check the next one. A and C. Now I'm going to compare A and C. So I'm done with this one. 6 on that one corresponds to 4 on this one. Is that the same proportion as 3, which corresponds to 2? So again, you check your cross products. And I get 12. 4 times 3 is 12. And 6 times 2 is also 12. So therefore, A and C are proportional. The sides are proportional. So the answer is yes. So A and C. The answer is rectangle C. Okay? So let's look at one more. By the way, I'll go into more detail on how to set up a proportion the right way on this one, in case you're not wondering where I put the numbers and why I put them in that spot. So let's look at example 2. So they're given the information that the triangles are similar. So we're given the fact that these triangles are already similar. So we're just going to use that data. And this would be 9 and x. So I have 2 triangles that are similar. I already know that they have corresponding sides that are proportional. And I know that they have corresponding angles that are congruent, meaning the same size. Matching angles are the same size. So I want to just use my rule of proportions to find this missing side. Now, you can ask yourself, 6 times what is 9? And that same number times 8 will get you x. But for some of us, it's not so obvious. So I'm going to label this as my first triangle and my second triangle. Because when I'm setting up my proportions, you always want to start with the same triangle when you're setting it up. You don't want to go back and forth and crisscross. So what I mean is, we're going to write a proportion that we're going to link 6 corresponds to 9 That's going to be one of my fractions. And I know that 8 corresponds to x. They are the matching sides. So that would be my second fraction. So when I'm setting up my fractions, you always want to start with the first triangle. So we'll start with 6 over 9 equals, again, start at your first triangle on the other side, 8, which corresponds to x. All right? Again, match the corresponding sides. Always start labeling them with the initial triangle. I'm going to start with this one as my initial triangle. So I go 6 over 9, 8 over x. Okay? Not just because people might do this, I want to make sure we don't do this. Don't say 6 over 9 equals, and then go to triangle 2 and say, oh, that matches x 8. Because you will not get the same proportion, okay? Don't do that. Don't go from 1 to 2 and then from 2 back to 1. That's why I numbered them. All right, so now that we set it up properly, we're going to cross multiply and see what x has to be. 9 times 8 is 72. And 6 times x I know is 6x. You have a one-step equation. And we're going to solve this for x, for x, which means we're going to reverse this multiplication of 6 by dividing. That's an invisible 1x. And 72 divided by 6 makes 12. So that means x was 12 in my triangle. All right, so that's how you identify similar figures and how we use similar figures to find the length of missing sides. There you go.